I'm sending the link on the chat again. The deadline is 12th July, 11:59 p.m. So hopefully enough time. Okay, I'll start now. So I hope everyone has gone through the project. Has everyone gone through the project? If you have any doubts, I'll explain the project a bit, or else we can start with the session. If you have any doubts, you can uh, put them in the chat. No doubts? Okay, anyways, I'll just, okay, one second. When we say process the file, is it like the user should pick from? Yeah, exactly. So, okay, I don't know if you've heard of the tool awk, but this is essentially just a clone of awk, Linux command line tool. So say we have this example.txt over here. So 1ABC, 2DEF, 3G, test P, right? So these are some space separated text file. So now you can do a bunch of actions with them. So the essential usage of this is you have some pattern, which is some sort of condition, and you can do some action. So the only action we want you to support is print. So for example, here we want some examples, right? So you want to print the lines where the first field is greater than 5, right? So now you run the pattern processor, $1 is greater than 5, then print $0. So $0 means it should print all the columns. Dollar hello, like that. Like if you want the second column, second field to be equal to hello, or the line number greater than 10. NR stands for line number and NF stands for number of column. So NF greater than 5. You want to contain hello, then it should just be a substring. You can put it like this. So stuff like this. So these are some of the ones supported. So the only patterns you need to support are a number of rows comparing to something. It should check if this token contains a substring regex, right? Then this thing, compare the nth column, compare row number, compare columns, like number of columns. That's all. That's all you have to support, and you should be able to chain like or and all of that. So an example of how it would work. 1 second. Uh, 1 second. Yeah, here you go. So as you can see, the input.txt is here. So 1 ABC, 2 DEF, 3 G test P, right? And now the command was the first column should be greater than 2, then print all the columns. So 3G test P. And if we want to just print the, say, first column, then we do this. So it will print 3. If you want to print the first column and the second column, you do this. Print 3G, like that. So those are just some of them. Say you want first column greater than 1 and second column should be equal to E, right? E. Then uh, first column greater than 1, second column equal to E. I don't know why that didn't work. But yeah, essentially stuff like this. So, okay, first column greater than 1 and first column less than 3. Then, yeah, 2D, stuff like that. Oh, second column was not equal to E in any case. That's why. My bad. But yeah, so say third column equal to E. Then, yeah, again, 2D, because here the third column is equal to E. So it should be able to support stuff like this. Or say number of fields should be greater than 2. Then number of fields greater than 2, invalid pattern. Why is it invalid? Anyways, uh, I will check that out. But yeah, you get the point of what we want you to do, right? The examples are given in the README. Just you should, if you can support the examples, you're most likely done. You will be able to pass all the test cases. Okay, then I'll start with the session if there are no more doubts. Yeah, exactly. We're trying to mimic this one Linux command line program, not the entire command line, obviously. But yeah, it supports basic features of Awk. Okay, then I'll start with the session. So today we're going to look through some advanced Git concepts, which are really helpful if you're working in a project with many people. Open source projects or just collaborating with team members in whatever place, a group project, a company, whatever. This will surely be useful if you ever plan to work with anyone else in your life. So hopefully you do. So yeah, we'll just teach you some more Git commands. So I hope all of you have attended our first session. It would be really helpful because I'll assume you know about the basic commands of committing branches. You know about commits. You know about branches. You know about remote repositories. GitHub is separate. Your local repository is separate. But if you are confused at any place, if I've assumed you know too much, just let me know in the chat. I'll explain it. So here I'll give you the first command. So git status. So this just shows the current state of your Git repository. So it will help you know, like you do know that if you want to add some files, like if you want to, commit some files into your next commit, you have to add them. So you use git add. Files which are not added, it will show that as well. So I'll show you here. Yeah, so this file is added here, so it's staged. So I have added test file.txt, but some I have not added yet. So awk.h. So git add it, or else if you don't want to add it, you can just restore it, like as in send it back to how it was in the latest commit, which is called head. So that's just a tidbit. Like the latest commit you've done in your repository is called head, HEAD, all caps. Right. So this just restores this file back to its condition in the latest commit, git restore, or you can add it. So this will help you know if you miss some file which isn't added, and some untracked files. So you can you can use a dot git ignore, which will say that okay, whatever files are in the dot git ignore, never add them, no matter what. Like even if I say add every file in the repository, it will not add it. So this is very useful if you want to exclude, like in C++ you'll have your dot out or dot exe files which you don't want to be added to the git repository, because every time you will be compiling, right? So it's just a waste of time to you know keep version history of all the compiled versions, because if you have the source code, that's enough. So usually the git ignore will have some exe files, some dot out files, some configuration files, stuff like that. So these will show up in your untracked files. So these are the three mm, like three categories which will show up in your git status. So it's always useful to run git status before you commit, because you want to make sure you're not committing some file which you made by mistake, or you're leaving out files which you have worked on in your commit. So it can help you get rid of some unnecessary commits. So are there any doubts for git status? Just put them in the chat if you have any doubt. Yes, no. All right then. No, no doubts. Okay, cool. So I'll move on. So git diff. So this helps you find the difference between two states of the repository, right? So now say you have a repository and you've made some changes, you've removed this line, now you've changed it, you've added a new line, stuff like that. Now you want to know what all changes you've made in the repository before you're committing, or you want to compare two commits, like, or you want to compare two branches, like you just want to compare two code bases and find out what exactly are the changes between. So that's the main use case of git diff, between two branches, between two commits, between some uncommitted work in the latest commit. So you can find out if you haven't made some changes you didn't want to make, or you've checked that like you haven't by mistake like removed an entire file which you didn't notice, stuff like that. So it's very useful to make sure that you are committing the right work you've done. You are not adding some changes which you don't need, some commented out code which will never run, like you had just kept it for testing, or some print statements, like you put some print statements to debug, right? But now you don't want those print statements in your final code. So this git diff will help you. So this is an example, like you have your test data, and I have removed this line, I had added this line, I've added a new line. So this git diff shows you everything. So does anyone have any doubts for this? Okay, I'll just show git diff by yeah, here you go. So now I will just clear, right? Now I have one test file. So I am going to say add some data change this um, word, right? And then I'm just going to blah 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 blah, right? And now I remove this. Now I uh, run git if. So now it will show me that I had removed this line and I've added these lines in this file. So I hope that clarifies it. Okay, so I'll move on. Git fetch. So this is a very simple command. It'll just download the changes in your remote repository. So your GitHub repository or GitLab or whatever. You have one repository which is somewhere else. You just download the changes. It won't change anything in your own computer, like no changes in your local code base. It will just download them and keep them for your use later. If you have, you can merge them later if you want to merge them, or else just keep them for later. So this is not used very often. The one which is used more is git pull. So you would have done git push in the first session, right? Where you have some files in your local code base and you want to send them to your remote code base. So now your remote code base has had some changes done, right? Someone has worked on it and they have also pushed. Now you don't want this outdated version of your code in your computer, right? You want the new latest version. So you just run a git pull, which will first fetch all the changes, so download everything, and then merge them. So it just gets your code base up to date with the new code. So you should always run this command before you start working on some new feature, some new bug fix, something, whatever you're working on. You run a git pull first so that you are with the latest code base. So yeah, there are there are some things you can come across if you run a git pull. You'll have some issues. Say both of you have worked on some work which is conflicting. Then now you'll be running into a merge conflict, right? Where say one guy has changed one file, you've changed the same file, same place. So now you have to decide what to keep, what to remove. Now you'll be doing a git merge or a git rebase. But this is a kind of complicated topic. People are scared of this. But yeah, I'll just give you an example using this flowchart. So now you are working on a feature, and this is the original code base, right? And you've been working on it for 1 week. You have these so and so amount of commits in your feature branch, right? And the main branch has also had some amount of commits. Now this feature is ready, and you want to merge it here. There are two ways to merge it, right? You can so the two ways are through a merge or through a rebase. So one way is through a merge. So now this git feature, this feature and this main, like they both, like both these branches join back, right? And then the next commit will be here in the main tree, and this branch would have joined here. So it just moves on like this, right? So that is a merge, but a rebase, you just add whatever commits you've done on top of the current commits, right? So now your feature has been added. So this star indicates that it's a new commit. So on main, you'll just have one new commit for a merge, but for a rebase, you'll have three new commits. All right. So yeah, so this commit is called a merge commit, right? So one second. Yeah, a merge commit will preserve the history of this branch and this branch. So um, you will keep these commits in this branch also there, so that you can understand what commits led to this point in your code base. But these commits are also there. One second, hold on. I'll be back in 1 minute. Yeah, I'll explain that. So yeah, in a merge commit, you'll have so as you move on, you'll keep adding features and removing features. You'll understand that these branches will just you'll always have these branches in the tree, right? Where they'll split and they'll join, and then they'll split again and join again. Like they'll split, they'll both join here, then they'll split again, join. You might have more splits with join later. Like imagine someone else was working into a feature here, and that joins here, right? So then tracking the history. So from here, you want to know what changes, right? Want to know what commits led you to this point in the code base. So first you'll have to check these three, and then you'll reach here, and then you'll have to check these two, and then like that, right? So with a lot of merges, it'll get quite complicated because there'll be so many branches. You'll have to keep branching up, checking which code is where, who committed what code. So it makes the change is hard to track, but it is simpler because you're not going to be changing the history in any branch, right? There'll be only one commit which will be added on this tree, so this tree remains pretty clean. But this commit will just be a merge commit which will add all these changes. So this branch will also have its history saved. This branch will also have its history saved, and there's just one merge branch. So it makes it easier to do. Like if you are running a merge, it's much simpler than running a rebase. Where in a rebase, you'll be adding three new commits into the branch, right? And it's just one clean tree. The tree continues in one line instead of branching out and joining back, branching out and joining back, right? So this does not preserve the history of which branch led to what feature, right? The feature is just added onto that tree. So you're not sure which branch, which pull request, which this thing did what, but they're all added, right? And your main tree remains clean. If you want to track changes, you can just go back, go one step back, go one step back, right? But from here you'll have to go back and then go back in another direction and maybe in another direction, like you don't. And obviously, since you are changing the history, like you're adding a large number of commits, and you're changing the history of main. Like main doesn't just have one commit; it has a bunch of commits starting from the latest thing. So you might mess it up. Like it's just a chance. People mess up rebases more than merges, right? But as long as you understand that a rebase is just adding the commits on top of this branch, right? Uh, you'll mainly be fine. Like just remember what a rebase does, what a merge does, understand them well, and then you can use them as you require. So mm, you might be asking when to use a merge and when to use a rebase, right? So merges in smaller repositories are perfectly okay because merges will not be very complicated. They'll keep your main repository clean, and they won't have a pollute it with a bunch of commits from other people, and it'll just be one feature on top of the next feature on top of the next feature. And since there won't be a bunch of complicated branches, it'll be fine. So merges are fine, but rebases are used more often when there are a bunch of people, like a lot of collaborators working together, because that it becomes easier to track who did what change, and it keeps the commit history clean so that you don't have to keep branching out to find out who did what. But both are very valid approaches. Like it doesn't matter if you're merging or rebasing in the long run, as long as you're getting work done. So don't break your head on whether to merge, whether to rebase. Both will work in fine generally, right? But rebases keep your commit tree clean. Like they'll keep your history clean, but merges will keep your history short and easy to read. Okay. Uh, any doubts? This topic can confuse some people, but if you have any doubts, you can ask them in the chat. All right, I'll move on then. Uh, okay, an interactive rebase. So now in your rebase, you will have a bunch of commits, right? And sometimes you would have added some commits which you don't really want on your main branch, which everyone sees, right? Those commits were for yourself, like they were tiny commits, or the message wasn't right, stuff like that. So you don't want these commits on the main tree. So now you can use an interactive rebase, which will help you decide, which commit actually makes it on uh, to the main tree and which what message is there and so on. So you can just edit your history quickly so that you can, your main tree remains readable and clean. So I'll have an example. So here I have done two commits into on my rebase branch, right? On my feature branch, I put one commit number one and commit number two, and they both have pick right now. I'll explain each command. So pick just means use it as it is. So now if I merge it onto the main tree, there'll just be one commit called commit number one on separate branch, and one commit called commit number two on separate branch. Right. So both these commits are added onto this commit ID, which is the main branch commit ID. So now the next could be revert, which just means edit the commit message. I want to remove on a separate branch because that makes no sense. Right. So I'll just call it commit number one, commit number two, or edit. Use the commit, but stop for amending, which just means you know like you'll edit what actually happens in this commit. Like I'll explain that in a bit. Wait, I'll just show what the these things. Squash just means merge the commits together. You don't want a commit number one and commit number two. Just put them as one commit with a new ID, right? With a new message which you'll write here, right? Which you've squashed. Fix up, it's like squash but keeps only the previous commit logs, right? So that's self-explanatory. It'll just keep this message, right? And now these are more complicated. You use them less often. So now this interactive rebase is essentially like it just runs a bunch of commands on the command line. So if you want, you can just execute some commands in the middle as well. Like you can, if you need, like I've never used this personally, but if you want to, I don't know, you want to print out a file in the middle, make sure you're committing the correct file and all. You can just run that command using the shell, like echo a file or add another file in between the commits and so on. Drop, remove the commit. You don't want to add this commit. Like that could be valid, like in one commit you've actually just put some debug statements. You don't actually need the debug statement, so you can drop them. Label reset, you want to head just means the latest commit, like how I said, right? So you actually don't want to write head all the time. You label it with some name, right? Or reset it back to head. A merge, like I had explained, this commit is called a merge commit, where you're merging two branches. So you want to merge the branch, so you can merge two commits, and they'll create a merge commit. Like there'll be a commit called merging commit ID this and commit ID that, using a message. Or if you want, you can add your own message, right? So these are a bunch of things you will be using in interactive rebase. It seems kind of intimidating at first, but you can use them as you need. Like right. You can use them as you need. Like most of these, you don't really have to do in interactive rebase. What is more common to use is, revert some commit messages or squash them. You don't want to commit everything at once, right? So you don't want to have 10 different commits for a very small feature. You just put it in one commit. Or you can remove a commit or remove a couple commits, right? So any doubts? Okay, I'll get back to rebase at the end. Okay, fine. I'll explain rebase again, but edit. I didn't explain edit properly, but what edit does is when it's going through, like this is pick, next is pick, then I put an edit. So that means that this edit command will just stop the rebasing. It'll just stop right there, and you can do some changes, and then it'll continue rebasing. So I'll do an example. Uh, Yeah, so about rebase, you have this feature branch, you have this main branch, right? Now you have this main branch here, and you want to, you worked on this feature. Now you want to add this feature onto the main branch, right? So now to add this feature onto the main branch, you can say this commit is adding the feature, this commit is adding some tests, and this commit is I don't know adding another feature, for example. Now you just add these commits on top of this tree. So I'll run a rebase, I'll run an interactive rebase, and I'll explain and I'll show you the commit history once it's done. But essentially, the graph will look like this. Like you'll have the two of these commits, then three of your own commits, right? I'll run it once. Any other doubts before I go to the Okay, no doubts. I'll just run some things. Right. So I'm on this new branch. I've created a brand new branch, a git checkout new, right? So I'll just show you the history. History is some bunches of commits which I've done, right? So let's add some commits. So I'll just, say add a new file, uh, which has some things, this is a new file, right? So I've added a new file. That's all. Okay. I'll just commit this. So git commit add a new file. Okay. So now I have committed this, right? So now there's this add a new file commit right at the top. I hope you can see my cursor, but yeah. So say I make a change to this. So new file txt um, change file. Now I have changed the file. I'll commit this again. Change the new file. Right. So that was my new branch. I'll now switch back to the main branch. Okay. Now I have this new clean main branch. Now I actually want to make a separate file. I'm working on a different feature. So new file. And I've added some new text. Okay, and now I'll just commit this. Right. So now on main, I have this one new file, this thing, and the rest here. But if I switch to my new branch, and now I have now I go through my log, I have this added a new file, change the new file, right? So now I want to merge these back into the same branch, right? I want main to have these branch. Now I will do a git rebase of new, right? So now it has successfully rebased. Now I'll go through the log, right? So now you have a this thing, add a new file, change the new file, and then new file, right? Because I had made that new file commit last. Now you have 1, 2, 3 commits all onto the main branch, right? So I hope you understood rebase better now. Please confirm on the chat if you've understood. Like, I'll just show the log again. Yes, understood. All right, cool. So then I'll move on to the next. Okay, force push. So, now you've made some changes to the commit history, sometimes when rebasing, sometimes when merging, sometimes when just doing your own work. And now Git is not letting you push to this remote repository, you know, because there are some conflicts or uh, there have been some changes made over there, and this this tree has now diverged. Like over there, you are here, you actually in this tree has diverged here. But you want to forget about these two commits. You just want this main branch to come here, right? That is a use case. It's not often, but it could be possible. So sometimes you just want Git to just listen to you and do exactly what you're telling, and stop telling you to try merging, try rebasing, or do something. You just put a dash dash force, right? So that just tells Git that, hey, I know what I'm doing. Just listen to me, and you push it. You just whatever commits have been made in the remote repository, forget about them. You just push them and do exactly like how it is in my repository. So this is quite dangerous because now you are rewriting the entire remote repository's history, which is really dangerous. What if that you have this divert branch, right? You have this yeah. So what if someone did some really important work in these two commits? Now, if you do a force push, you just directly go here, right? So now you don't want it to directly go there if there's some important work here. You want to preserve this work and join them, in either a merge or a rebase, right? So that's why it's called dangerous, and most people don't recommend doing it. But sometimes you do want to do it. So, at any time, if you want Git to just listen to you and do as you're telling it, you can just do a dash dash force. So, another thing which could be used is dash dash force with lease, right? Which just checks if the remote repository has had any changes since the last pull or fetch. So that just means that you are trying to push. You don't know that someone has done some work and pushed it here, and you're just trying to push and figure it out. If you put a dash dash force with lease, it won't let you because it'll say that someone else has done some work here. You should check that out first. So that's just a safer way to use so that you don't overwrite someone else's work, right? So that's all. It's just these dash dash force and dash dash force with lease just is trying to tell Git to just listen to you and do as you're telling it, like, or else it'll cry about some merge conflict or the other. Dash dash force just says you know what you're doing and you just want it to uh, go as you're telling it. Okay, so git cherry pick. Git cherry pick is a command which enables arbitrary commits to be picked by reference and appended to the current working head. Right. So cherry picking is just picking a commit from another branch and adding it to your current branch. You don't want to merge the entire branch. You made like 10 commits which you don't need. So you just commit it. You just cherry pick the one commit you need and you add it to your current branch. And it could also be useful for undoing, like in your branch you've made some changes in the middle and you don't actually want those changes, so you just cherry pick the commits which you need, right? On one more useful case is you were on the wrong branch, right? You were working on one branch and you realized that, oh no, this work was supposed to be on another branch, and just switch to that branch and cherry pick that commit and send it back to the branch it belongs, right? So I will explain this using my command line because that's the best way to understand this concept. Okay, so say I I move to a new branch, so I check out to this new branch called useless branch because I just need to do some work here. So take the new file, um, and this commit was supposed to be in main, but I have also done. So I'll just commit this. Right, so I've committed it. Now I have a new, I actually made a change in this other file also. Um, these changes are not supposed to be in main, right? So now let me commit this. Okay, so now if you see the history, you have this one commit which is not supposed to be in main, but this commit which is supposed to be in main, right? You need this to go to the main thing. Now let's switch back to main. We could switch main, and you're like, hey, I need that commit back. So you can, so now you use a cherry pick, but you need the commit ID. So I'll just switch back to the useless branch and remember the commit ID. So here you go, the commit, this is supposed to be the uh, commit which you need in main. So just copy that. So 0C52BEB, or else you can remember it as well. Now you switch back to main and see, this does not have those commits and you need them here. So you can just git cherry pick that commit ID, enter. Now this commit has been added to main. So now if you check the log, now this supposed to be in main commit has been added to main. So if you check the new file txt, this commit was supposed to be in main. It's there, right? So this is the way you use git cherry pick. I hope you can think about some places you might use it. All right. Uh, if you have any doubts, you can ask them in the chat. Till then, I'll move on to the next one. Git stash. So git stash allows you to temporarily save some changes which are not ready to be committed, but you need to go to some other branch and quickly do some work because that is more urgent. You really need to do that, but you don't want to lose all this work. But it's not yet ready for a commit, right? So this again, I will explain through the command line because it's much easier to understand that way. So one second. Um, switch. Okay. So now I'll clear. So in main, you have been um, say working on this new file. Okay. And this is a sentence. This is some work which is income. Oh shoot. I have to go somewhere, right? I have to quickly switch to the branch. But I don't want to commit something which is incomplete, right? You are midway. Commit is not ready. Like you don't want this on your history yet. So now you just run a git stash. So now this git stash has saved it here. Like I have this extension on my command line which will show the stashes and changes and all. But essentially, you can see all the stashes through git stash list. Now you have this one stash which is at index 0 on main branch on top of this commit called supposed to be in main commit. And so this stash has saved all your changes. So if you actually check new file.txt, that sentence will not be there, right? That incomplete sentence is not there yet. And now you can, switch to your branch and, you can do whatever work you want, like some work you need, like say it. Um, okay, fine. Right? You really needed to check something. Now you've done your work. So now you can switch back to main and git stash apply 0. So you apply the first stash you have. Now you have applied it. So if you check new file.txt, you see this work is that sentence is back. Like you haven't lost your work. Now you can complete it. Right? Now this work is no longer incomplete. It's complete. Right? But yeah, like one thing you can do using this is also um, you made some changes on the wrong branch. Again, this time you haven't committed yet. Like cherry pick is something you can use if you've made some changes on the wrong branch and you've committed them. But this time you're lucky, you've realized that you haven't committed them yet, right? So let me clear the stash, right? I've cleared all the stashes. So now if you do a git stash list, there's no stashes. And now I can switch to the useless branch and let me apply it here. Oops. So now the work is on my users branch, not on the main branch. So this is another way to save your work if you've been doing it on the wrong branch. All right. Git remote. So these are just a bunch of commands. Like you won't be using git remote as it is, but git remote allows you to work with repositories which are stored on the internet, like GitHub or GitLab. So you can add git remote remote repositories. Like you have a GitHub repository, and you're working on it on your local computer because obviously you don't want to work on it on GitHub, right? So you'll just add a remote. So git remote add, and you'll add that the link on how to. GitHub has a tutorial on how you can add a GitHub repository onto your local thing and remove them. So if you've added a remote repository, you can quickly pull all the changes, push the changes as you need, right? If you, so in I'll show an example, but if you see, you would have added a remote repository, remove it. You can remove them if you need. I'll show this at the end. This is quite simple, and you won't be using it much. Like you would max be using it once in your entire project to just set up and everything. But yeah, so that's what get remote does. To get revert, this is the last command I'll be doing today. But yeah, get revert is used for undoing changes. So there are many ways to undo changes. Get reset and get revert are the two main ones. So get reset just forgets about that commit. So I'll show it. But yeah, get reset is just removes that commit from your history and keeps the changes. But get revert will add an extra commit at the end, which just says, this commit is removing the previous commit. That's all. And it's called a revert commit. So I'll explain here. So now I have added commit number one, commit number two, and commit number two on separate branch. Now I want to revert this latest commit 80.056993, which is called head also, just a short like shorthand for the latest commit. So I revert it. So now it will add a new commit called revert commit number two on separate branch, which will change one file, blah blah blah. So now if you look at the log, it's commit number one, commit number two on the separate branch, and revert commit number two on the separate branch. So I'll explain remote and revert at one go. So now I'll just commit whatever changes I've done. So this commit should not exist. Right? So now I've committed it. So if you see the log, this commit should not exist is right at the top. Okay. So now I'll revert it. So git revert that latest commit is called head. Now I'll revert it. This is the commit message, right? The message you want to be written there. So just revert this commit should not exist. You can change it as well. So you want to add this is reverted. So it will add this, and now it's done. So now if you see the commit history, the revert that revert commit is there, but this commit is still there, right? So you can see you can if need be you can keep the work as well, but if you see the file right now, you see that work is not there, right? But now you have these extra revert commit. So this is useful if you want to keep those changes, like those original changes which you had done. You might use them later, you're not sure, but you don't need them now. You can revert them. So there's this extra commit which makes sure you don't lose those changes. So you can also reset it. So reset git log. So say you want to forget the previous two commits and reset back to this commit. So you copy the commit ID, and now you just get reset to that commit ID. Now it has reset. So if you see the log, now it's just back to that commit ID. If you see that file, yeah, that work is not there. So that's the difference between reset and revert. Revert just adds the commit, reset doesn't add the commit. So for git remote also, so git remote, that remote is called origin. So I can say switch to main, and now you call the git remote, still called origin. Now you can get remote help. So you can add a remote, rename the remote. So say my remote, instead of calling origin, I want to call it something like, I don't know, origin 2. Now it's called, oops, my bad. Now it will be called origin 2. So if I see the list, we called origin 2. So say, I want to pull, so git pull origin to main. That's how I do, right? So it's already up to date. Great. So that's all. Like if you want to pull or push to some repository, the remote will just keep the name of it and the branch. Right? The remote name is origin 2, the branch is name. That's all git remote is. So if you have any doubts, you ask them in the chat. I'll send the attendance link. Okay, that is the attendance form. You can all put your attendance there, and this is the feedback form. Please give me feedback for this session. Could you explain about the project? Do you want any particular explanation about the project, or else I'll just run a quick demo again and explain what you have to do. Okay, I'll explain briefly. Fine. One second.
Advik, you're on mute.
Thank you. I did not know. Sorry. Yeah, I'll start again. Sorry. My bad. Uh, I'll take 5 minutes extra because of that. My bad. But yeah. So essentially, it's a pattern-based file processor which will, read your file, read this pattern, uh, read a pattern by saying, it should follow these things. Using that pattern, run an action. So the action is the print statement, right? So I'll explain the code a bit, and then I'll come to the examples. Now you have this header file, which you don't have to do anything with the header file, but you have to read the function statements, see how they work. Like, you have a parent class and you have child classes of print statement, and the action parser will take in an action, parse it, and then run it. Like you need the action parser to run something when you run it. Print statement, it's a type of statement, and when you run it, it should print as required. Pattern parser, it should check the pattern, and taking. So I'll explain how the file would work exactly. So you take the file and you send the file name to it. So this I've given some extra reading if you want to do. You don't have to do it, but yeah. So this is called move semantics. If you want to read up on it, you can search up std move, watch some YouTube videos on it. But yeah, uh, so this file should take in the file name, and then it should run. This constructor should take in the file name, and it should run it, and it should parse it into a vector of strings. So that means that each line will be one vector of strings, and each string will be one word. So A, B, C, A space B space C, enter D space E space F, become a vector A, B, C, vector D, E, F in a vector, like that. So then the pattern passes. So you go through each line and you check the pattern. If the pattern is correct, then you run that line. That's all. Okay. So this is your uh, template. So I've given some comments. So read the comments, figure out what you need to do. So yeah, here you go. Like the file parser will, parse it into a vector, and it should return that if you need. So here it should parse all the patterns into a vector if you need. You can read it up, ask any questions you have on the WhatsApp group. We can help you out. But yeah, this is what the function should do. So on. I think the explanations themselves are more than enough. But if you have any doubts, you can ask on the WhatsApp group. Um, right. So yeah, what is this? So this is an example file. So you include a header file. You have this CPP function, and you complete the rest of it. So I'll just run the program so you can know how it works. So let me clear this up. So this is the uh, input file which will be which it's just an example input file, which is called 1abc2df3g test p, right? So now I have the code, so dot out and a pattern. So say you want the second line, right? So you want nr, I don't know, second and third line. So nr greater than 1, and you want to print the entire line. So print $0, okay, and input .th. Now it will print second and third line 2df 3g test p. But say you want only the first line, so less than 2, you will print only the first line. You want only the first and the second column, so you do this. You print the first and the second column. You want the first and the second column of all, it should be like the first column should be equal to 1, or the first column should be equal to 2. So it will be printed 1A and 2D like that. So this is just how it works. So you should be able to do exactly how that is working. I hope that has cleared up everything. Okay, then. If you don't have any doubts, you can leave. If you filled out attendance and feedback, you can leave. Yes, it's the last code process.